Imagine standing on the shore of an endless sea. The air is still. The waves lap quietly at your feet. You look out, but there is no horizon, only water, stretching infinitely in all directions. A single, shimmering sphere, floating in a vast, silent expanse of other realities. Now, imagine that each drop in that ocean is an entire universe, beyond the edge of our known universe, into a place where reality may not be singular, but plural. Our universe, with its stars, its galaxies, its swirling nebulae, its delicate lattice of space and time, could be one such drop. The idea of the multiverse, a cosmos made not of one reality, but of many, emerges from the deepest theories of quantum mechanics, relativity, cosmic inflation, and string theory. Would the laws of physics hold true in these other realms? Could there be another version of you out there, somewhere, living a different life? Tonight, we drift far beyond the stars. You may wonder, how could there be more than one universe? Where would they exist? How would they form? This is not science fiction. It is a possibility born from the most serious minds in physics and cosmology. In this journey, we will gently unfold the layers of this idea. We will begin where all things begin, with the Big Bang. And from there, we will slowly step out across time and space until we find ourselves standing once again on that silent shore, wondering who we truly are in a universe that might not be alone. Let us begin. Before we speak of many universes, we must first understand the birth of this one. Our story begins with nothing, no space, no time, no before. Then, a singular moment, the Big Bang. But the phrase, Big Bang, may be misleading. It suggests an explosion, a detonation in space. But this was not an event in space. It was the birth of space itself. In less than a trillionth of a second, everything that would ever be matter, energy, laws of physics erupted into existence. The universe expanded not into something, but into being itself. There was no outside. There was no edge. Time, like a newborn river, began to flow. Space unfolded with a speed and violence we can scarcely imagine. The universe became uniform, the same in all directions, and remarkably flat in its geometry, but with quantum uncertainty baked into its fabric. Tiny fluctuations, like faint ripples on a pond, were frozen into the expanding space. Imagine something the size of a proton growing to the size of a galaxy in less time than it takes light to cross an atom. And in those first moments, the infant cosmos was a hot, dense sea of particles, quarks and leptons dancing in wild, random currents. Electrons settled into orbit around nuclei. Atoms formed, light could finally move freely, not with detectors. We are confined within a cosmic sphere roughly 93 billion light-years across. This was the moment of the cosmic microwave background, the earliest light we can still observe today. This early universe did not simply grow, it inflated. The early universe was still opaque, like a thick cosmic fog of light and plasma, but it was beginning to organize itself. According to the theory of cosmic inflation, a fraction of a second after the Big Bang, the universe expanded exponentially, doubling in size again and again in a flash of unimaginable speed. This sudden, blistering inflation smoothed out the wrinkles of the young cosmos, like heat flattening a sheet of crumpled silk. Inflation, in some models, is eternal. New universes may be forming right now, not beyond our galaxy, or beyond our stars, but beyond the limits of reality as we know it. Each might have different physical laws, different particles, different forms of time or gravity. Some may be lifeless, others stranger than we can imagine. But the idea arises not from fantasy, but from the math of our best cosmological theories. These faint ripples would one day become galaxies. But even this rapid inflation was only the beginning. After a fleeting instant, inflation stopped, or at least slowed. In our region of space, matter and energy cooled. Particles began to combine. Just 380,000 years after the Big Bang, a blink in cosmic time, the universe became transparent and may differ greatly from the forms in others. We begin to see the outlines of something larger and feel the silence of space unfolding. And this moment of first light is the edge of our observational universe. Beyond this point, we cannot see, not with telescopes. But what lies beyond? Here is where the idea of the multiverse begins to whisper. Because if inflation happened here, it might have happened elsewhere too. Some theories suggest that our universe is just one bubble in a vast, inflating field of space, a field where new universes continue to bud off like droplets in boiling water. These other bubbles would be forever separate from us, drifting endlessly through the great inflating sea. And the engine that gives rise to these bubbles, it might never stop. Pause for a moment. Consider the possibility that our entire universe, with its 100 billion galaxies, each holding hundreds of billions of stars, is but a single breath in an infinite chorus. We cannot observe these other universes directly. They are, by nature, unreachable. And so, from the birth of our universe, in the next chapter of this journey, we will explore the great structures that arose within our universe. Stars, galaxies, black holes, the forms and forces that define our reality. But first, let your mind rest here. From the swirling chaos of the early cosmos, order began to emerge. The once blazing universe cooled, and gravity, that quiet, persistent force, began its long work. It gathered clouds of gas, drew matter into knots, and from these knots, the first stars were born. These stars were nothing like the ones we see today. With no heavier elements, they burned hotter, lived faster, and died more violently than any star since. The ingredients of life. And in some collapses, something even stranger was born. Black holes. They were titans, vast, searing giants composed only of hydrogen and helium. Astronomers call them population 3 stars. Some collided, some merged, some were torn apart. Over billions of years, the large-scale structure of the universe took form, an immense cosmic web. Filaments of matter stretching across unimaginable distances, with galaxies clumped like dew at the intersections. Their deaths were cataclysmic, supernova that scattered stardust across the universe, creating the first oxygen, carbon, iron. These were the seeds of galaxies. Some quasars shine from the farthest corners of the cosmos, their light taking over 13 billion years to reach us, relics from a universe still in its infancy. Galaxies, vast islands of stars, gas, dust, and dark matter, began to swirl across the cosmos. These giants shaped their galaxies with invisible hands, affecting the formation of stars and the motion of matter. Black holes spiraling toward one another, merging in a final, silent embrace. These collisions send gravitational waves, ripples in space-time, echoing across the universe, unfolds within the bounds of our own universe. But what of the others? Could they sparkle with forms of light we cannot imagine? We have felt them faintly through instruments like LEGO, like placing your hand on the skin of the cosmos and feeling its pulse. And at the heart of most large galaxies, a monster waits. The frontiers where possibility unfolds into multitudes, not just about how our cosmos works, but how rare or common our form of reality may be. Supermassive black holes, millions or billions of times more massive than our sun, spin silently at the center of galaxies. Asterisk, asterisk. Sometimes they awaken, not to devour stars, but to shine. When a supermassive black hole feeds on matter, it can ignite into a quasar, a beacon of light so bright it can outshine its entire galaxy. And then there are the great collisions. Galaxies crashing into galaxies. Stars flung into new orbits. But for all these visible wonders, stars, galaxies, black holes, we are reminded that what we see is only a fraction of what is. The universe is held to matter and dark energy. guiding galaxies and shaping time itself. Guiding galaxies and shaping time itself. All of this beauty, all of this violence and grandeur. If other universes exist, what would their stars be made of? Would they even have stars? Could their black holes obey different laws? We do not know. We cannot know. Not yet. But as we study these great cosmic objects, as we peer deeper into the structure of our own universe, we gain clues. And in the next segment, we will enter the most mysterious realms of all. The places where science teeters on the edge of speculation. Let your mind drift now across galaxies, through light years, into the unknown. Close your eyes for a moment and imagine another version of you, somewhere in another universe. Perhaps you made a different choice, took a different path. Perhaps gravity is stronger there, or stars are colder. Perhaps there are no stars at all. This is not merely fantasy. It is one of the most serious questions in modern cosmology. Could there be more than one universe? The idea of a multiverse, a vast collection of universes, each with its own laws, constants, and realities, arises from multiple, independent corners of physics, like separate rivers flowing toward the same mysterious sea. Let us begin with eternal inflation. But in some models, inflation never truly ends. Instead, it continues in the wider cosmos, endlessly creating bubble universes, each one inflating, popping into being, then evolving independently. In our own early universe, the rapid expansion known as inflation eventually slowed and stopped, allowing stars and galaxies to form. We live in one such bubble, but there could be others, perhaps an infinity of them, forming beyond the limits of what we can see. In some, gravity might be so strong that stars collapse instantly. In others, no atoms can form. In a few rare ones, life may arise. Each bubble may have different properties. These strings may only be consistent if reality contains 10 or even 11 dimensions. That our universe is not fundamental, but computational. If so, perhaps there are other simulations, other codes running in parallel, other realities with their own observers, questions, and dreams. Most of these are curled up, invisible to us, but the landscape of string theory allows for countless possible universes, each with different physical constants, like tuning the strings of a cosmic instrument. We cannot measure them, at least not directly. They are, in a sense, unprovable, but they are also inevitable in the mathematics of our best models. They are not fairy tales, but logical extensions of what we observe. Then there is string theory, which suggests the universe is built not of point-like particles, but of tiny, vibrating strings. Some universes might have 4 spatial dimensions, Some might have none. Others might contain particles or forces we've never imagined. If an electron can go left or right, it does both, and the universe splits. If you choose coffee or tea, the universe splits. And in this infinite, branching tree, every possibility happens. Perhaps we are the only bubble, the only branching path. But perhaps not. Now, consider the many worlds interpretation of quantum mechanics. Perhaps the most radical of all. In this view, every quantum event, every flip of a coin, every particle path creates a branching of the universe. You are reading this sentence in one world. In another, you stopped. In yet another, you were never born. These are not universes beyond the edge of space, but ones layered on top of ours, like infinite sheets of invisible paper, each holding a different story. Back to the blue planet that looks up at the stars. Then, there is the simulation hypothesis, the idea that all of this may be a projection. The possibilities are dizzying, and yet each of these theories arises from serious attempts to explain our reality. Still, we face a mystery. If these other universes exist, we cannot visit them. So, where does that leave us? In a strange and poetic place. Perhaps we are alone, after all. Perhaps we are one universe. In the sea of universes, each pulsing with its own kind of time, its own kind of light. To ask, how did the chaos of the cosmos shape the quiet possibility of life? Let your mind settle now and prepare to descend from the multiverse. Drift with me now through the star-speckled darkness, across millions of light years, until we return to one pale blue dot, Earth, spinning quietly in a narrow band of warmth around an ordinary star in an ordinary galaxy, and yet, somehow, extraordinary. We often forget, surrounded by sky and soil, that our planet is not separate from the universe. It is the universe. Every atom in your body was forged in a star. Every breath you take is part of a cycle that began with the cosmos itself. But in a universe of possibility, Earth's story is a rare one. How did we get here? About 4.6 billion years ago, a swirling cloud of gas and dust, the leftover debris of earlier supernova, collapsed under gravity's pull. At the center of this cloud, a new star ignited, our sun around it. The remaining dust clumped into planets, some rocky, some gaseous, some flung into deep space, never to return. Earth was born hot, violent, and molten. It was struck again and again by massive objects, one of which likely gave birth to the moon. And yet, somehow, this chaos gave way to calm. Water appeared, a crust cooled, atmosphere formed. Life emerged. Why here? Why this world? Scientists speak of the Goldilocks zone, a narrow orbital band where it's not too hot, not too cold, but just right for liquid water. Earth lies within that zone, but even this is not enough. Our planet's magnetic field shields it from solar winds. Our large moon stabilizes its rotation. Our plate tectonics recycle carbon. That, in the vast dark, planets like ours may number not in billions, but in handfuls. The chance alignment of so many life-supporting factors is staggering. In that case, we find ourselves in this one not because it's common, but because it's the only kind of universe where observers could exist to wonder about it. Some call this the rare Earth hypothesis, the idea that complex life may be vanishingly uncommon in the universe. Others believe that life is inevitable, that given enough time and space, it arises wherever conditions allow. But here's where the multiverse changes the question. To the eyes we've raised to the cosmos above. If there are countless universes, each with different laws, different values for gravity, chemistry, or time, then perhaps most of them do not allow for life at all. This is called the Theanthropic Principle, the idea that the universe must permit life, because life is here to observe it. It's a strange loop of logic, and yet it offers a kind of perspective. We are not guaranteed. We are not inevitable. We are the product of a very specific cosmic history, a timeline of precise balances, improbable survivals, and quiet convergences that made Earth what it is, a planet on the edge of possibility. And so we must ask, how does a planet born from stardust and gravity begin to look up and ask where it came from? In the next chapter of our journey, we trace the long, human gaze into the heavens, from ancient myths to modern observatories, from the first questions whispered to the stars, to the machines that now peer into the heart of time itself. Let your breaths slow as we turn our attention from the earth beneath our feet. From the moment we first looked up, we've been reaching out, long before telescopes, before equations, before language even had a name for universe. Our ancestors stared into the night sky and wondered, what are those lights? Where did we come from? Are we alone? The stars became gods. The heavens became maps. Constellations were carved into memory, passed from voice to voice, carved into stone, traced in firelight. We watched the sky not as observers, but as participants, linking our stories to the stars above. This was the first astronomy. In ancient Mesopotamia, Egypt, and Mesoamerica, civilizations tracked the movements of celestial bodies with surprising precision. They aligned temples to solstices, predicted eclipses, and saw divine rhythm in the movement of planets. The sky was both clock and calendar. Then came the revolution. They proposed and proved that Earth was not the center of everything, but a planet orbiting a star in a galaxy among billions. With it, he saw craters on the moon, moons orbiting Jupiter, and the phases of Venus. Evidence that the heavens were not perfect and the Earth was not unique. Hubble revealed that our universe is not static, but expanding. Galaxies flying apart like seeds from a dandelion. In the 16th and 17th centuries, thinkers like Copernicus, Galileo, and Kepler began to challenge the Earth-centered cosmos. Galileo's telescope was small, but it changed everything. From that moment forward, our vision expanded. Newton gave us gravity. Einstein gave us space-time. We built ever larger instruments. The Mount Wilson Observatory, where Hubble peered into deep space. The Arecibo dish, whispering to the stars and listening for replies. We send signals, not knowing if they'll ever be received. The Hubble Space Telescope, which showed us galaxies colliding, stars birthing, light echoing from the edge of time. And now, the James Webb Space Telescope peers even further, not just through space, but through time, capturing light that has traveled over 13 billion years to reach us. It is about meaning. We search not just for facts, but for context, not just for stars, but for ourselves. With it, we see the first galaxies forming. We glimpse the chaos of the early universe. We also reach outward with spacecraft. Voyager 1 and 2, silent messengers now drifting beyond the heliosphere, bearing golden records of Earth's music, languages, and dreams. Perhaps, in other universes, beings like us wonder as we do, building telescopes of different shapes, speaking languages of gravity or light. We scan for exoplanets, measuring the faint dimming of starlight to find distant worlds. Some of these lie in habitable zones. Some may have oceans. Some may have atmospheres. We've begun to study those atmospheres, searching for biosignatures, hints of life in the chemistry of distant air, and our place within it. And still, we listen and ask, what comes next? SETI listens for whispers from civilizations we have never met. Our tools have grown more precise, but at heart, we are still those same skywatchers, curious, vulnerable, yearning. The human gaze into the cosmos is not just about data, and perhaps for others. If we live in a multiverse, perhaps other civilizations do too. Or perhaps we are alone, the only creatures to look up in a sea of universes that do not know they exist. Either way, we are here, and we are looking. And now, in our final segment, we will turn our gaze forward, beyond this night sky, beyond our current understanding, into the far future of the cosmos. Let your mind soften as we drift toward time's horizon. Let us drift now into deep time, a time beyond memory, beyond planets, beyond stars. The future of the universe stretches ahead of us, cold, slow, and uncertain. But even now, in this quiet moment, you and I are part of it. Part of a story still unfolding. Let us begin with the fate of the stars. It will cast off its outer layers and shrink into a white dwarf, a hot, dense ember glowing in the dark. Massive ones will explode as supernova, leaving behind neutron stars or black holes. Over billions of years, fewer stars will be born. The galaxies will grow dim. In about 5 billion years, our sun will swell into a red giant, swallowing Mercury, Venus, and possibly Earth. Other stars, too, will burn through their fuel. Eventually, only long-lived red dwarfs will remain, their slow burn lasting trillions of years. But even they will fade. One day, there will be no more stars, just darkness and cold. This is the heat death of the universe, a state where entropy reaches its maximum and no usable energy remains. All matter will decay. Black holes will evaporate through Hawking radiation, disappearing into nothing over unimaginable timescales. After all is gone, only silence will remain. A dark, empty universe. But some theories suggest otherwise. In the Big Crunch, gravity could one day halt expansion and reverse it, collapsing the universe into a singularity, perhaps leading to a new Big Bang. We imagine Dyson spheres, structures built around stars to harness all their energy. We imagine post-biological life, consciousness uploaded, scattered across the stars. In the Big Rip, dark energy might grow stronger, stretching space until atoms themselves are torn apart. And in more speculative theories, the universe could tunnel into a new vacuum state, a false vacuum decay, in which our laws of physics are rewritten in an instant. But what about us? Will humanity survive to see these fates unfold? Perhaps new universes are always being born, in black holes, in quantum fluctuations, in realms we cannot imagine. Some dream of interstellar travel, of escaping Earth, colonizing Mars, building space habitats, or traveling to other star systems. If we survive long enough, perhaps we could shape the cosmos, steer planets, birth stars, even engineer universes. And yet, there is another possibility, that we are early, fragile, temporary, but perhaps the search itself is enough. That, in a universe full of possibility, we are a brief flicker, not its rulers, but its momentary witnesses. And what of the multiverse? If other universes exist, with different fates, different laws, different meanings, then perhaps death here is not the end of all things, Perhaps consciousness echoes elsewhere. Perhaps this is not the end, but a transition. And then, finally, we must ask the oldest question of all. Why is there something rather than nothing? Why this universe? Why these stars? Why you, sitting quietly in the dark, listening to the history of everything we may never know? 8. To ask the question, to look into the sky, to wonder, because no matter how many universes there are, no matter how far the future stretches, no matter how dark the night becomes, may your dreams be full of stars. There was a moment when the universe looked at itself and saw you. Closing reflections. Thank you for drifting through the multiverse with me. If your mind is still awake, I hope it is calm. If you've fallen asleep, and if you ever feel small, remember this: you are not in the universe. You are the universe, briefly remembering itself. Until next time, stay curious.